Hey guys, in this lesson we're going to be talking about radical operations. We're going to take a look at adding, subtracting, multiplying, and dividing. Recall that when we're doing operations of any kind that we want to leave them in simplest form. So remember that for radicals to be considered simplified, there should be no perfect squares, no fractions in the radicand, and no radicals in the denominator. Let's get started with adding and subtracting. When we're adding and subtracting radicals, our goal is to combine like terms. Like terms in this case will be any terms that have the same radicand. That's the number underneath the radical symbol. So I'm going to look at example A. Each of those terms has a radicand of 2, so those would be considered like terms. When we're combining like terms, we're going to add the coefficients together. So our coefficients in this case would be 3, 7, and minus 6. So we're going to add or subtract depending on the sign that's in front. So when I'm adding, I'll get 3 plus 7, which is 10, and 10 minus 6, which will give me 4. And so our new coefficient is going to be 4. Then we take the radical and we rewrite it as just one radical. So we'll have 4 square roots of 2 as our simplified expression here. When we look at B, we have 5 square roots of 3 plus 2 square roots of 2 plus 3 square roots of 3 minus 4 square roots of 2. Here we have two sets of like terms. We have 5 square root of 3 and 3 square root of 3 because they have a like radicand of 3. And we also have 2 square roots of 2 and 4 square roots of 2 because they have a like radicand of 2. Now let's combine them. Remember that we're going to add the coefficients together. So for the square roots of 3, that'll be 5 and 3, which will give me 8. And we rewrite the radical as 1, so 8 square roots of 3. For the square roots of 2, that would be 2 minus 4, which would be minus 2. And we rewrite that radical as 1. So here our simplified expression is 8 square roots of 3 minus 2 square roots of 2. Now let's look at C. Here we don't see like terms yet, but we need to simplify these expressions first. So as I'm simplifying, as we move into this process, we want to simplify each of those radicals. So remember to simplify, we are going to factor, we're going to break up each of those radicals into its factors until we can find perfect squares. So 80 breaks up into 8 and 10, 8 breaks up into 2 and 4, and 10 can break up into 2 and 5. Here we have a perfect square of 4. And the other numbers are prime. So I'm going to rewrite the square root of 80 as 2 times 2 times 4 times 5. 2 times 2 happens to give me 4, which is another perfect square. And I know that 4 times 4 gives me 16, which is also a perfect square. And this will help me with simplifying. So I take the square root of that perfect square. So in this case, take the square root of 16. And I pull that out from underneath the radical. So that would give me 4. And I'm left with 5 on the inside. So my simplified form here would be 4 square root of 5. If I'm looking at 20, here I've got the square root of 20. I'm going to break 20 up into its factor. So in this case, that would be 4 and 5. And so 4 is a perfect square, 5 is prime. I'm going to take the square root of that perfect square. And I'm going to pull that out, so square root of 4 is 2. And what I'm left with on the inside is 2 square roots of 5. So the square root of 20 can be rewritten as 2 square roots of 5 when it's in simplest form. The last one that we need to take care of is the 180. So again, really breaking it up into its factors helps us figuring out what it simplifies to. So 180 is 10 and 18. 10 is 2 and 5. Both of those numbers are prime. 2 and 9 will give me 18. 2 is prime, 9 is a perfect square, so I'm going to leave that. I'm going to rewrite this as 2 times 5 times 9. I know that if I were to combine 2 and 2, that would give me 4, which is a perfect square, and 9. And then I will take the square root of both of these perfect squares and pull them out from underneath. So the square root of 4 is 2. Square root of 9 is 3. I'm going to multiply those together since I pulled both of them out. And I'm left with the square root of 5 on the inside. And so my simplified form here would be 6 square roots of 5. So now that I have them all simplified, we can see that they are like terms because they all have the same radicand of 5. And so now let's combine them. Add or subtract those coefficients. So in this case, I'm going to do 4 minus 2 and then plus 6. So 4 minus 2 is 2, plus 6 is 8. And so my simplified form here would be 8 square roots of 5. All right. Let's take a look at multiplying. When we're multiplying radicals, we're going to multiply the numbers outside the radical sign together, multiply the numbers underneath the radical sign together, If there's variables, we'll add their exponents when we multiply them, and then we'll simplify. So let's take a look at this first example. Here we have 2 square roots of 3 times the square root of 21. Since there's only one number on the outside of the radical sign for both of these terms, I'm just going to rewrite the 2, and then I'm going to move on to that next step, which is to multiply the terms on the inside. So I'm going to multiply 3 and 21. 3 times 21 gives me 63. Now I want to begin the process of simplifying. The square root of 63 is not yet simplified because I can simplify 63. 63 can break up into 9 and 7, where 7 is prime and 9 is a perfect square. And so I can rewrite this as 2 square roots of 9 times 7. Now, we want to take the square root of 9 and we want to pull that out from underneath the radical symbol. So if I remove the square root of 9, that would give me 3. And as I'm removing it, I multiply it to whatever number is already on the outside. So because there's a 2 there, when I pull out the 3, I'm going to multiply it to the 2. And so that's going to give me 6 square roots of 7, which is what I was left with on the inside. So my simplified expression here would be 6 square roots of 7. When we look at b, we actually want to simplify these first because it'll be a little bit easier for us. We know that the square root of 25 is 5. We know that the square root of 36 is 6. And so 5 times 6 gives me 36. Or not 36. 5 times 6 gives me 30. And so there is our simplified form there. When we look at c, we have 3 square roots of a. We have the square root of 3a times the square root of 5a squared. Again, we want to simplify before we start multiplying things together here. Simplify first, and it'll make your life easier in the long run. So I can't simplify 3a because that is already in simplest form. So I'm just going to rewrite that over here. But I can't simplify the square root of 5a squared because a squared is a perfect square. If I were to take the square root of a squared, that would give me a. And so I could rewrite this as a square roots of 5, since we couldn't pull out the 5. All right, now I want to multiply them together. Remember that we multiply the terms on the outside together. So because there's only one thing on the outside, I'm just going to rewrite that. And then we multiply everything on the inside together. 3 times 5 is 15. And a is the only a on the inside, and so we just rewrite that. We carry that over. And so our simplified form here would be a square roots of 15a. Now, we want to make sure that 15 can't be simplified further. Can we break up 15? We can break it up into 3 and 5, but those are both prime. And so I cannot simplify that piece any further. So our simplified expression here would be a square roots of 15a. All right, let's take a look at d. So if we're looking at d, again, we're going to do the same thing. I want to simplify first. So I could take the square root of 4, and I could take the square root of y squared. Square root of 4 would be 2. The square root of y squared would be y. And we're left with the x. Don't forget about the x on the inside. We're left with x on the inside. We do the next one. I cannot take the square root of 6, and the factors of 6 are 2 and 3, and those are both prime. So we're going to be stuck with the square root of 6 on the inside here. But x squared is a perfect square. So if I pulled out the x squared, that would just be x on the outside, and then we would be left with 6y on the inside. And so now we can multiply here. Multiply the terms on the outside, so multiply 2y and x. So that would be 2xy. I'm writing them in alphabetical order. And then the square root, multiply things on the inside, that would be x times 6y, which would be 6xy. And so here our simplified form would be 2xy times the square root of 6xy. All right, when we're multiplying, we can also use the distributive property, and we will see this throughout this unit. The square root of 2 times the square root of 8 would be the square root of 16, which could be simplified down to 4. And then the square root of 2 times the square root of 4 square roots of 3, that's going to be 4 square roots of 6. The square root of 6 cannot be simplified, and so what we're left with is 4 plus 4 square roots of 6. I cannot combine, we cannot add them together because 4 and 4 square roots of 6 do not have like radicands. If we look at f, we have 4 square roots of 5, 4 plus the square root of 5 times 3 plus the square root of 5. Here we would FOIL, so we would do 4 times 3, which would be 12. 4 times 5, which would be 4 square roots of 5. 5 times the square root of 3, which would be 3 square roots of 5. So if I have a whole number and a radical, this is how we just rewrite it like we would any other, just like it was a variable. And then we have 5 square roots of 5 times 5 square roots of 5, which would be the square root of 25, which in this case could be rewritten as 5. And then now let's combine like terms. 12 and 5 are like terms, so that's going to give me 17. And 4 square roots of 5 and 3 square roots of 5 are like terms. I would add the coefficients there, so that would give me 7. And then rewrite that as 1 coefficient. So 17 plus 7 square roots of 5. All right, lastly, let's move into dividing. So when we're dividing radicals, again, we're going to simplify the numerator and the denominator, and then we're going to make sure that we're in simplest form. We cannot have any fractions underneath the radicand, and we cannot have any radicals in the denominator. All right, so here's what we're going to do. If we're going to do the square root of 49 over 81, I could break this up so that it's the square root of 49 over the square root of 81. These are like expressions. I know that the square root of 49 is a perfect square, that's 7. The square root of 81 is also a perfect square, that's 9. And so my simplified form here would be 7 over 9. Now when we look at b, again, the same thing. I'm going to break this up. 18x to the 4th over 200, over the square root of 200. I'm going to simplify both the top and the bottom. So when I'm simplifying 18x to the 4th, break up 18 into its factors, that'd be 2 and 9. And so the square root of 18 x to the 4th could be rewritten as the square root of 2 times 9, since 9 is a perfect square. X to the 4th. X to the 4th is also a perfect square. Let's pull out those perfect squares. So square root of 9 is 3. The square root of x to the 4th is x squared. Remember to divide the exponent. And then we're left with the square root of 2 on the inside. So here we have 3 x squared times the square root of 2. And then we have 200. 200 can be broken up into 2 and 100. 2 is prime. 100 is a perfect square. And so I'm going to rewrite the square root of 200 as 2 times 100. I'm going to pull out the square root of 100, so that'd be 10 square roots of 2. All right, so this one's actually nice because we have the square root of 2 in the top and the bottom, and there's no addition or subtraction taking place. These are actually going to cancel each other out, and we do not end up with a radical in the denominator. So my simplified form here would be 3x squared over 10. Again, because those were the same and there was no adding or subtracting happening, we could simplify it that way. Let's look at this last example. So here we have 28s, square root of 28s over the square root of s cubed. Now, s cubed can be rewritten as square root of s cubed can be rewritten as s squared times s, and we take the square root of s squared, which would be s, so we end up with s square roots of s. So there is what we have in the denominator. Now for 28, we have 28 can be broken up into 4 and 7. Let's do that, that's easy. 4 and 7. So we could rewrite the numerator as 4 times 7 times s. 4 is a perfect square. I could factor that out, or square root that out. The square root of 4 is 2. So it's going to be 2 roots of 7s. Now, this one's a little bit different because we have the square root of s and 7s are not the same. So on this one, I'm going to have to multiply everything by the radical that's in the denominator. So I'm going to multiply everything by the square root of s. In order to clear out the radical in the denominator, we multiply by that radical in both the numerator and the denominator. So if I multiply by the square root of s in the top and in the bottom, let me give myself some space here. What we're going to end up with is 2 times the square root of 7s squared. So remember that when we're multiplying, you multiply what's on the inside, and s times the square root of s squared. And so what we end up with is, when we simplify this part, we can pull out the square root of s there, or of s squared. That'd be 2s and the square root of 7. And same thing here. This would be s times s now, since the square root of s squared is s. And so what we end up with is 2s square root of 7 is s squared. And then we're not done yet. Because I have the s in the top and the s squared in the bottom, the s in the top cancels out with one of the s's in the bottom. And so our final simplified form would be 2 square roots of 7 over s. Now I know that was a lot, and we're going to practice with rationalizing the denominator a little bit more in the next video, but these are our basic operations.